So I didn't get anything done this week other than thinking about stuff. And somewhere along the line, Bob said, "Can you post some pictures of how you mounted your encoders?" And I was thinking that, well, Al has talked about this all along, where he talked about, buying those encoders and making 3D brackets and then figuring out how to, 3D print his gears and mount them on his vehicle. So I was thinking, back in the index for this group, there are times when he was talking about that. So I was looking at it and I found one that said something about Al talks about his magnetic encoders. And it says Al talks about mounting speed sensors on his wheels. And I was going to pull those up and look at them. And one of the problem, the particular computer I have didn't have the videos on. I could have gone out to YouTube and watched them there, but I was just going to watch them on my local computer. And it turns out I've got back about half of the videos are on my computer, and the other half are on a hard drive that's kicking around. And just this morning I found that hard drive, so I'll try to make a point of going back and just as an exercise here, I'll say Bob wants to know about this, and then say show the list. Wait, we could do this next week if I get around to it, and say here on the list it says here Al talks about this, Al talks about this, or he shows his speed encoders. And then once I find that, I'll put up links. I can just put them on Slack and say, here, these videos is where he was talking about it. And I think somewhere either in this group or back in the ROS Agriculture stuff, I think I was showing my wheel encoders. And I've got those quadrature encoders. They look like a potentiometer, but they're actually quadrature encoders. And I just made a little bracket to bolt it on. And then on the vehicle back here on the, there's a like a 3-inch diameter gear pressed onto the shaft behind the wheel. So then I got another gear on my encoder, and they just pushed it so it's meshed together. And that's how I mounted the stuff on mine. And Al and I were just talking about the fact that some people will take, say, on your vehicle like this, instead of putting thing right on the axle or right on the wheel, some people have you can put like a bracket up here that runs down, and then have an encoder mounted on the outside that just simply comes in and hooks onto the end of the shaft that's sticking out. And you can either, like with Al's sensors, you could just glue a magnet onto the shaft, and then this little sensor board would see that turning. Or if you're going to use like a rotary encoder, you could either, I'm trying to remember how these work. I don't know if they have a threaded hole in the end of the axle, or if it's got just a flat axle sticking out. But you could glue something on there, say glue a little shaft sticking out. Like say, since I need like a 1/4-inch shaft to do that, I could just take a 1/4 bolt and just bolt that on with either epoxy, or glue it on with epoxy or super glue or something. So that way I'd have a little tiny shaft sticking out the end, and you could put a coupler between that and a quadrature encoder that would be hanging down. And so that's just a thought on that. And then I also remember the Greenzie people had, basically they had on the vehicle here, they had like right here somewhere, they had this thing bolted on. There was an arm that would pivot and it would come back here, and they had one of those cheap Chinese encoders and a little rubber wheel, and it would actually rub on the top of the wheel. So that way you could just stick it on without having to, get in and modify the frame and all that kind of stuff. And that way, as the wheel turns, the top of the wheel is going by the same speed the bottom of the wheel is going. So if you got this rubber wheel rubbing against the top of your, I assume you can see my cursor here. Anyway, so it has this rubber wheel on top, and I think it even comes with a spring, and you can just buy those on Amazon. And I was looking at them one day, and I don't remember the prices, but that'd be another option. So you just simply, bolt the thing on up here, assuming you can see my cursor, and it has an arm that comes out here, and then either have the weight of it holds it down, or I think they might come with the spring, so the spring can pull the rubber wheel against your drive wheel. So that's another way just to get, if you want information from your wheels, that's another way to get that. And probably we think about this, just specifically say sometime, how can we measure those wheels turning, and how can you get that information? We might come up with lots of different interesting ideas, but that's what I can think of right offhand. So that's essentially what I was thinking about. So I guess that's all I got. So we'll take questions from Al, or Al can just take over here.
Let's get off of mute. Let's see. For me, um, yeah, Jeff was talking a little bit there about managing information, and let me get sharing going here. There's the Zoom screen. Um, Bob's query prompted me to post some pictures out on Slack, and it also prompted me to go back and put some things in my Miro board. So I just put a link here down near the representation of the rotation sensor. So keeping all that stuff in this link is goes to one of the folders in the GitHub. So I always struggle with keeping all this stuff straight, and I'm, I'm tending to return to this Miro board, which helps me keep things organized. But that's still quite a maintenance job and can get out of date. I also added here on the left and right sensor a file that it's just a text file, but it's the output from the last compile, which I have to remember to actually keep the compile. And the part of the reason I was doing that is I was having some issues, and I was wondering how much memory was being um, used by the program, and nervous that maybe somehow I had gotten to some level of memory usage that was dangerous. And the only way to do that is, well, that I knew of, was to go back and look at the compile data, but I didn't have it. So anyway, I just decided it's useful to keep the output from the last compile and put that in the GitHub in one of the archive folders, and then made a reference here. So anyway, just a little bit more um, info on trying to manage all this. There's a ton of data that sort of flies around in these things. So since we last spoke, I have updated my code on these um, sensors to try to fix a speed issue, and I think I've gotten that nailed. Previously, I was thinking there was some malfunction in the actual sensor when it did a rollover, and now I've concluded that I was trying to sample at 100 hertz, average 10 of those readings, and feed that into um, the actual publishing of the speed, which was going on at 10 hertz. And I think in that logic, I was not averaging correctly. And so I cleaned up that code and updated it on those. And I'm getting speed values. This is not plot juggler, it's an example of it. And I know that it's terribly small, but what I'm not getting negative, other than sort of vibration things. I'm not getting these dramatic highs and lows. It is more believable now, as far as my top speed and slow speed on my left and right wheel. So I think I've made some progress on that. I also have, as Jeff had mentioned or probed about before, I've got this Python program that is creates an ODOM statement, and it's getting it from both partially the GPS, partially the wheel data. And so I've gone back and updated this in a couple of ways, and that was I added I'm only publishing from those wheel sensors one topic, and it's a multi-array. I think 4 pieces of data in there. One of them is speed, one of them is rotation, one of them is delta. And yeah, I had to come back in and change this program to get that and stop using 2 different topics. So that's a little bit of housekeeping that's gone on. I also added that if I have RTK fixed, I'm going to take the linear velocity and get it from the GPS. If I don't have RTK fix, then I'm going to get linear velocity from the wheels, so that although I don't have a ROS topic for speed specifically, I am updating the twist message with the actual speed, and this is calculated either by the GPS movement or the wheel movement, again dependent on whether I've got RTK fix or not. So that's another change that I've implemented. And so at this exact moment, I am trying to adjust my PID for my speed control, because this is under remote control or autonomous control, and it's, as you can see, varying from well below 0.5 meter a second to above 1.5 meters a second. And I've got to get that under better control. I found some documentation. I mean, I adjusted a PID before and just done it sort of, I'll call it the brute force way of getting P to move, and then as best you can, and then adjusting I and D based on that. But I found some documentation on this tuning rules, and what they basically say is go get your P to a point where it's oscillating, and they call that your KU, and then use that value, take 60% of that and make that your new P, and then go ahead and give it an I and D at the same time. So I haven't done that yet, but I found that and thought, hey, I'll give that a try and see how that works. The current status, if I can find, let's see, which program is that in? That'll be over here in Tractor. I've run a 6 steps or tests trying to get to that KP that seems to generate a reasonable number. This number like 325 and 305, that's a value that's fed to the servo that controls the transmission, which ultimately controls the speed. I'm trying to get to a KP that generates about a 310, because based on manually driving it, 310 is decent. And that's, literally it's not completely arbitrary, but that's just dependent on the physical design of the servo. So anyway, I need to do it a little bit after the call. I'll do a little bit more testing and try to get a KP value that's reasonable, and then I'll go back and do that calculation and update my I and D integral and derivative, and see where we go. So still trying to get a consistent speed is where I'm at, and making a little bit of progress testing. One other thing that I wanted to just point out when I was doing testing was make this this is ODOM, the position data plotted out, and this red line is where I'm running a uh, a planned mission. Start at this point, go to that point. There's look ahead of I think 2.5 meters and points every, I don't know, half a meter maybe, I've forgotten. And I drive the robot over to about this point and turn on auto mode, and it has this really wonky behavior. And when I look at command velocity angular z, these oscillations represent the time period when it's here. And so as it gets closer to this look ahead point, it stables out. And I haven't put pen to paper to try to figure out what that, I'll call it steady state error between that blue line and that red line is, but you can visually see it's off the line and not trying to correct it. So I still have some PID tuning on the steering to go as well. But I just thought it was interesting that angular Z is all over the place until it gets closer to that. So what I did is I changed my path to start up here closer. So when I get to actually testing them, I'll maybe call it integrated testing with the steering and the throttle, I'll get some more data about how do I get that blue line, more over to the top of the red line. Anyway, a little bit of progress, more data, sticking at it, tenacious. That's it.
On that picture you got right there, you've got that red line that you say you started on the right, and then the blue line tries to follow the red line down. Down in the left-hand corner, is there kind of a glitch in the red right there? Is that your GPS changing back and forth, or what is?
Yeah, I can't say for certain. It does it. I don't know what is causing that, to be honest, Jeff, because I'm not near trees. The tree line is, over in this area. So I've got clear line of sight. So I'm not sure what triggered that glitch. Unless the red line represents the look ahead. And when I change from auto mode to manual mode, I don't know. I'd have to go back and look at my code to see, or the code to see where it's pulling look ahead data from. So that might be, look ahead might become current position somehow when I go to manual mode.
Okay. I noticed in the upper, if you go back to the left there, you said you started up there and started moving. It looked like you had a
Oopsie.
looked like you had kind of a couple of glitches there too, and I didn't know if that was your GPS kicking in and out, or that was. I doubt if you're actually driving that, driving like that, but
Yeah. So this is the tractor is parked under sort of a lean-to under trees, and so this is the GPS losing RTK, and it's because of tree coverage.
okay.
Anyway, getting more data, doing more testing. That's where I'm at.
Yeah, that's all I got, I guess. Anything else from you?
Nope, I'm good.